Good morning, everyone. I welcome you all to this wonderful session of hands-on experience with the test facilities at the Department of Ocean Engineering, IT Madras. I am Dr. JKG, Assistant Professor in the Department of Ocean Engineering, IT Madras. Of the various test facilities in the Department of Ocean Engineering, IT Madras, we are presently in the glass plume test facility. The dimensions of the glass plume test facility is 22.5 meter in length, 0.6 meters in width, and 0.8 meters in depth. The total depth is 0.8 meters, which means that we'll be restricting our water depth to less than that value. So, for any given test facility, we have the wave generation on one end and the test zone in the middle and wave absorbing zone in the other end. So, we'll be placing our model in the test zone, which will be minimum 2 times the maximum wavelength that we'll be dealing with the test facility. In this test facility, you can generate waves from 0.8 to 2.2 seconds, so which can be scaled up to deal with the prototypes. Here you can see the waves are generated in the test facility because of the piston type wave maker we have on one end. In the present session, we will be dealing with the oscillating water column wave energy converter. In this, there is no moving body. Only the waves which is traveling from one end will get trapped in a chamber and they compress the air, because of which we have through a nozzle we will be seeing a varying in the pressure, which will be converted to an usable power. As said earlier, of the 3 zones, we are presently in the test zone wherein we will be placing our model. The advantage with the glass plume is that we will be able to see the wave structure interaction very nicely from one side, which may not be possible with the facilities wherein there is no glass plume, provided. So here you can see that model which has been built with an acrylic and it is placed nicely interacting with the waves. The waves are generated and the waves, here you can see that the waves get trapped in this particular zone and they get excited, and there is a pressure sensor which will measure the varying in the pressure, and there is a wave probe which will measure the varying in the surface elevation, which means that we will have a trapped zone. When the waves come from the one end, they get trapped in the zone and the air in the zone gets compressed, and that is measured using the pressure sensor, and the surface elevation is measured using the wave probes. Here you can see the surface elevation, and there is a clear difference between the surface elevation in front of the structure and in between the and in the trapped zone. Here, because of the air which is already present, there is a elevation difference that is happening, and that is nicely measured using the wave probes, and the pressure is measured using the pressure sensor. 2 types of mechanisms happen with the oscillating water column. One is the piston mode, one is the sloshing mode. For small period waves, you can see sloshing mode, whereas in case of a long period waves, you can see a piston mode. So when we say piston mode, it behaves like a piston of a massless piston basically, wherein the complete elevation moves in sync. In the sense, they will not have any slamming on the front wall and the back walls. We are presently standing in the wave absorbing zone. Passive absorbers are presently used here, but then the recent developments are with the active absorption. The advantage with the passive absorption is that no power is required for absorbing the wave, and if you leave it for some time, the waves get settled. Whereas in case of an active absorption, it will also move out of phase with the waves that is coming, and because of which the suppression of waves will happen quickly. So generally there used to be rubbles also to absorb the waves, to dissipate the wave energy. However, because of the test models that we had in the past, there are no rubbles. However, we have a porous plates at the end which will dissipate the waves. Thank you.